Hello guys, how are you? Welcome to my channel. In previous video, I explained how to work with Simulink, and in today's video, I'm going to tell you about the other side of MATLAB, which is coding environment. To start that, we're going to tap on New Script, and this is where we can use codes. In this video particularly, I'm going to teach you how to work with different and basic signals. For example, impulse signal, step signal, some other signals such as sine and cosine. So let's get started. First thing to do is to determine a period. For example, write x then equal to, our period should be depending on what we want. It can be everything. For example, mine is -10 with sampling rate equal to 1/10 until 10. This is our period. And hold on, it's not. Alright, so next thing is to determine our function. So for example, y equal to, so here I'm going to first use step signal. The name in library for a step signal is Heaviside, and the MATLAB library is very strong. For example, I typed HEA for Heaviside, and you can see it's available here. I just need to click on it, and in parentheses I just need to write X. So I told you sampling rate. Sampling rate is important when it comes to discrete, not for continuous. For example, if I want to show what's happening right here, if I want to show it in continuous, I write plot. You can see it right here, and in parentheses, I have to write x as well as y. If I run this section, you can see that it starts from -10, goes all the way to 0 with 0 amount, and then goes up to 1 after the 0. But this one was continuous. If I want to show the discrete, I can simply type stem. Stem is the type of the discrete one. You can see that here is discrete, but the samples are very close to each other. What I'm going to do is to change the sampling rate. If I change it to 5/10, for example 6/10, and run section, you can see that the samples are a little bit separated from each other. If I increase it to 1 and run section, you can see that the samples are separated one by one, and these are seconds. 1 second after that there's another sample, and 1 second, and so on. Also, I can add, for example, double the amount of the signal, or for example, multiply to 3, 4, whatever I want. For that, I introduce another unknown parameter. For example, z equal to 3 multiplied to y, which is our function. And instead of y in plot or a stem, I write z. And if I run section, you can see that the maximum amount is 3 instead of being 1. This one was step signal. For impulse signal, the name of impulse signal is, hold on, is DIRAC, DIRAC. I'm not sure how to pronounce it. And I need to write X here. And one more thing I'm going to do is to add more than 0. This one, hold on. X more than 0. This needs to be done. After that, I just need to plot it. Plot and X and Y. Hold on, let me correct the sampling rate. And then run section. If I run section here, you can see that this is my impulse signal. But because of my sampling rate, you can see that signal is really close to reality. In reality, the signals are not going to be perfect at all. For example, if I increase it to 100, you can see that it is completely near to perfection. But in this grid area, where I can write stem, it's obvious that it's perfect because it's only one sample in 0. Lastly, we have our sine and cosine. For that, we need to write just sin, sine, and determine our x here, and then plot x and y, x and y. No. All right. So in this period, with this being our function, if I run section, you can see that our signal starts from -10 and it goes all the way to 10. I can as well shift it and do whatever I want. That's it, guys. Thanks for watching. See you in the next video.